Okay, so we're looking at simplifying the expression and then identifying, okay, what will be referred to as restricted values. Okay, and I'll get to that in just a moment. Now, in looking at simplifying the ratio we have here, okay, so we got x squared minus 9 all over x squared minus 4x minus 21, and here we can simplify this ratio. Now we have with x squared minus 9, okay, again we have a difference of squares, and looking at factoring, okay, so we have with x squared, this will go to x and x, and then for minus 9, okay, notice there's not an x term in the middle, so that means that you'll have zero sum for the outside and the inside products. Okay, so you're going to have the same weights for the addition and the subtraction. So we'll have x plus and x minus 3 for x squared minus 4x minus 21. Okay, so we have x squared, which will factor to x and x, and factors of negative 21 whose sum or difference will be at negative 4. So we're going to have more weight given to the subtraction than to the addition. So here we're going to have x minus 7 and x plus 3. And if you notice, between the numerator and denominator, okay, we have a common factor with x plus 3. Okay, so we can get these to cancel out. And so for the simplified version of what we have here, this ratio reduces to x minus 3 all over x minus 7. Okay, so this will be the simplified form. Now, in terms of what they have regarding restricted values, okay, and now to be defined, now we have the denominator cannot be 0. And that is for fractions. Okay, for a fraction to be defined, the bottom value cannot be 0. In other words, you can divide into 0, but you cannot divide by 0. And so, again, for what we have with the denominator, okay, so again, we have the denominator is x squared minus 4x minus 21, and what we have in x cannot allow for x squared minus 4x minus 21 to be 0. And again, just looking at the factors, we have with x minus 7 and x plus 3. This cannot be 0. So what we have for x minus 7 cannot be 0, and x plus 3 cannot be 0. So we have with the restriction that the denominator cannot be 0. Okay, that means the factors cannot be 0 either. So if x minus 7 cannot be 0, we have the x cannot be 7. And as for x plus 3, this cannot be 0. So x cannot be negative 3. And so we have two exclusions for x, 7 as well as negative 3. Okay, so even though x plus 3 canceled out, we still have the precondition that before any cancellation or reduction, whatever we have that was set the denominator to 0, it cannot be any of those values for x. So 7 and negative 3 are disallowed, and those exclusions will be the restricted values. Again, so we have 7 as well as negative 3. Okay. And also in the case of rational expressions, now we have a little bit of a repeat, okay, because we have for this next ratio, we have the reappearance of difference of squares. Okay, and this time we're working with the variable y, so we have y squared minus 64 all over y squared minus 7y minus 8. And for y squared minus 64, if we factor, now just as x squared goes to x and x, y squared will go to y and y. And for negative 64, okay, we have a difference of squares, so factoring will have the same weights in the addition as well as the subtraction, so we have plus 8 and minus 8. And for y squared minus 7y minus 8, again we have y squared goes to y and y. And we have, looking at factors of negative 8 whose sum or difference will be at negative 7. Again, we're going to have more weight given to the subtraction than to the addition. So here we're going to have a minus 8 and a plus 1. Negative 8 times 1 is negative 8. Negative 8 plus 1 is the middle coefficient, minus 7. And so looking at what we have in reduction, so y minus 8 is shared, and that will cancel out. And then we have, for the simplified form of what we have in number 18, this will go to y plus 8 all over y plus 1. And again, looking for the restricted values. Once again, the denominator cannot be 0 in value. So again, we have with the factors, again we have y minus 8 and y plus 1. Okay, so the trinomial cannot be 0, and the factors from that trinomial cannot be 0. So we have for y minus 8, that cannot be 0, and y plus 1 cannot be 0. So we have from y minus 8, okay, we have that y cannot be equal to 8, and from y plus 1, y cannot equal negative 1. So for the restricted values, okay, again, you're just identifying, okay, what is excluded in the variable we're looking at working with. So again, we have the restricted values. They have 8 as well as negative 1. Okay, now in looking at what we have with the next item, all right. Okay, so I have 8x minus 3y over x cubed y to the 4th. And we have times 6xy to the 8th all over 24x minus 9y. All right, and we're going to have some reductions that will be involved. Okay, so we have 8x minus 3y. Okay, and all over x cubed y to the 4th, and we have times 6xy to the 8th all over 24x minus 9y. Okay, and now out of the expressions, okay, that we can factor, okay, we have 24x minus 9y, so we can factor out positive 3. And so for what we have in the layout, okay, so we have with 8x minus 3y again, we have all over x cubed y to the 4th. We have times 6xy to the 8th. Okay, so for 24x minus 9y, we have 3 times the quantity of 8x minus 3y. And if you notice, looking at what appears, okay, we have 8x minus 3y to be a factor of 24x minus 9y. And so we can cancel what we have here. And also, we can do this either before or after. And I tell you, we'll just bring this on down. And you can reduce the 6/3 right away. But I'll just present the next steps to include, okay, 6/3. So you have, in this one, okay, so you got 6xy to the 8th all over 3x cubed y to the 4th. Okay, now we have in the reduction, okay, so you have 6/3, have a 2-to-1 ratio. And for x over x cubed, now there's a little item referred to as the quotient property of exponents. So in a way, you could look at this as where we have 6 times x. If you have just x, that means this is the same as x to the first. And in terms of reducing, notice that the degree in x is higher in the denominator than it is in the numerator. So for what we have here, in the reduction, we're going to have x to be in the denominator. So we can say we have x raised to the 3 minus 1 in the denominator. So you're looking at taking the lower power in the variable away from the higher power, and where the variables will be located, it'll be where the higher degree term is situated. Okay, now for y to the 8th over y to the 4th, the higher power rests in the numerator, and so we're going to take 4 away from this, and so we have for the end result, we're going to have 2 times y to the 4th, and this is going to be all over x squared, and that'll be the final result in this one. Okay, so you have 2 times y to the 4th all over x squared. Right. Now, where we have crossing over, okay, to working with addition of rational expressions. Now we have, in the case of number 41, so you have m squared all over m plus 3, and we have plus 6m plus 9 all over m plus 3. Okay, so we're not multiplying, we're just adding. And if you notice, both rational expressions have the same denominator. So that means we can go ahead and combine the numerator terms together. So we're going to have m squared plus 6m plus 9 all over m plus 3. And for this ratio, okay, I can reduce. Okay, now for m squared plus 6m plus 9, again, that is going to be a squared trinomial. So once you factor, you have m plus 3 times itself. Again, we have all over m plus 3. And so we have m plus 3 common to both the numerator and denominator. And so we have, for the sum, we're going to have for the reduced form, the outcome is going to be the binomial m plus 3. Now, in looking upon what we have in the next setup, so we have for number 43, okay, so we're looking at adding expressions, and this time we have the variable to be the letter C. Okay, so for number 43, So 2 over 9c. And we have plus 7 over 15c cubed. Now I'm just kind of mentioning, okay, so you're looking at finding a common denominator. And if we're looking for the least common denominator, and just sort of going back, okay, say if we have for the number 9. Okay, so you have looking at the prime factorization, so 9, that is going to be 3 times 3. 3 is a prime number, so 9 is 3 times 3. And as for 15, 15 goes to 5 times 3. And both 3 and 5 are prime numbers. Again, prime numbers are counting numbers whose positive factors will be that number and the number 1. So you have with the prime factors. Okay, so we have 3 and 5. And again, for the variable factor, okay, we have just the letter C. Okay, so we have in writing what we have for the least common denominator. Okay, so looking at the prime factors, now 3, you're looking at utilizing the greatest number of appearances from each of the factorizations. Now with 3, it appears once from 15, but from 9, okay, it comes about twice. And as for 5, it doesn't come at all from 9, but from 15 it does appear once. And in the case of the letter C, we're just taking the highest degree that appears for C, or the higher degree. In this case, that's going to be C to the third. So we have with the least common denominator, we have 3 times 3 is 9, times 5 is 45. And we have times C to the third. Okay, so the least common denominator is going to be 45 C to the third. And just taking what we have with the ratios. Okay, so I'm going to write both of these fractions in terms of the denominator. 45c cubed. Okay, so we have, so I'm going to multiply the first ratio by 1 in terms of the number of times that 9c will go into 45c cubed divided by itself. So we have 9 will go into 45 5 times. And c will go into c cubed, c squared times. And as for 7 over 15c cubed, okay, so we already have c cubed, and so we're going to multiply this ratio by 1 in the form of, okay, where we have 15 into 45 will be 3 times. And now for the final result, okay, now we have both denominators. We have 45c cubed. And so we have combining the numerator expression. So we have 2 times 5c squared, so this would be 10 times c to the second, plus 21. So we have 10c squared plus 21 all over 45c cubed. Now, in the case of what we have with number 48, okay, so again, we're looking at variable expressions. And this time we have 4 over m minus 2. And we have minus 3 over m. And for what we're going to have in the setup, okay, for the least common denominator, Okay, we have just the variable factors have m and m minus 2. So least common denominator is just going to be the product of these respective denominators. And so for what we're going to have in the setup, raising both ratios in along the lines of least common denominator. So you have 4 over m minus 2. Okay, so here we got the m minus 2 factor, and taking this into the least common denominator, we still have m left over. Now minus, then we have 3 over m. And again, with the second ratio, we have the m factor, but we're missing the m minus 2. So the second ratio will be multiplied by 1 in the form of m minus 2 over itself. And just looking at what we have in carrying over, I'm just going to take this little extra step. So you have m times the quantity of m minus 2 as the denominator. Now from the numerators, I have 4m. Now if you notice, we have separating, we have the operation of subtraction. So you have minus 3, and you're going to have distribution all over m minus 2. And for what we have in terms of following through, okay, so you got 4m. Okay, then we have negative 3 over m minus 2, so this is going to yield negative 3m plus 6. So you have 4m minus 3m becomes m. And we have the addition of 6. All over m times the quantity of m minus 2. Okay, and so there are no common factors between the numerator and denominator. So m plus 6 is its own expression, as is just m as a standalone variable, and m minus 2 as its also its own binomial. Okay, so this will be the result for what we have in the difference that we have for number 48. Now, in taking what we have regarding number 52, okay, this time we have 3 ratios in the mix. Okay, so here we have 5 over t squared, and we have plus 4 all over t plus 2. And we have minus 3 over t. All right, now in setting up what we have for the least common denominator, okay, if you notice, okay, we have the standalone single terms in the denominator. We have t squared and t. Okay, so again, the least common denominator, okay, is going to be the higher or highest degree representation of t itself. Okay, so you have t, and we have t squared, a factor, so you have t squared, and then we have the binomial factor t plus 2. And looking at what we have among the 3 ratios, okay, so I'm going to raise 5 over t squared in terms of least common denominator. Now, we already have t squared, now we need the t plus 2. For the next ratio, okay, so I have for 4 over t plus 2. Okay, and this I have the t plus 2 factor, but I need the t squared. And perhaps the trickiest adjustment is going to be with the last ratio. And we have with t, and comparing it to t squared and t plus 2. Now t will go into t squared t times. Okay, so I'm missing 1 degree in t, but I'm also missing the entire binomial, t plus 2. And so in looking at what we have here, now throughout we're going to have the same denominator, t squared t plus 2, t squared t plus 2, t times t is t squared, and you still have times t plus 2. All right, and for what we have in terms of looking at the distributions among the numerator terms, so you have 5 over the quantity of t plus 2. Okay, so this would be 5t plus 10. And then we have 4 over t squared, so it would be a plus 4t squared. And for the last step, I'm just going to take this just a little bit further. So you have minus 3 times t. We have times the quantity of t plus 2. Okay, and again, if you have enough, I guess you can say intuitive insight to go ahead and carry this out, okay, that's fine. Okay, so we have these same terms again. Now for negative 3t over the quantity of t plus 2. So we have negative 3t times t. So this will be negative 3t squared. And negative 3t times 2 is a negative 6t. And for what we have in the follow through, it technically doesn't matter what order you place the terms, but I like to put them in reducing degree order. So you have in second degree, so I have 4t squared minus 3t squared, so this will be t squared. And I got 5t minus 6t, so this will be a negative t. Then I have the constant number 10 to follow. And t squared minus t plus 10 cannot be factored into integer coefficients. And then we have all over t squared times the quantity of t plus 2. And that will be what we have upon combining these ratios together. And now, just looking at what we have in the crossover. So these are just cases of working with fractions. And now, in terms of crossing over to what we're going to have with equations. And this is going to be sort of centered upon what we started out with when we looked at the FOIL method of various kinds, as well as factoring second order expressions. And in the equation realm, we'll be looking into quadratic equations. And then what we have for quadratic equations. Okay, so we have for a quadratic equation, okay, so we have, by definition, okay, so we have a second degree equation okay, whose standard form is going to be, okay, so we have ax squared plus bx plus c is equal to 0. Okay, and we're looking at second degree in the variable x, at least for the standard representation. And this will be with the restriction that the a cannot be equal to 0. And again, just for the second degree equation, this is in reference to the x squared in it. So we have ax squared plus bx plus c is equal to 0. And now, in terms of solving for equations, now there is one technique that can potentially be utilized. And this will be for what we have in the case of the zero product property. Okay. And this property states that if a times b is equal to 0, and this property is not limited to two terms, but let's say you have, in general, if a times b is equal to 0, then one of the factors must be 0. And in terms of how this is going to carry over to the quadratic equations, okay, and we're going to tie in factoring. And let's say that if we have, for instance, in terms of solving for x, okay, let's say if we have x squared plus 7x plus 12 is equal to 0. Right, so if we're looking at solving for x, okay, so you're looking for the values of x such that x squared plus 7x plus 12 is equal to 0. And in terms of creating the pathway, now we have this trinomial we can factor. So we have with x squared, again this will factor out to x and x. And for factors of 12, they'll add up to 7. So we have plus 4 and plus 3. And if the whole expression is equal to 0, then at least one of the factors must be 0. And so looking at the value or values of x, so we have x plus 4 is equal to 0 is one possibility. And the other possibility we had to stem from x plus 3 is equal to 0. And if we have the x plus 4 is equal to 0, we have that x is equal to negative 4. And if x plus 3 is equal to 0, then we have that x is equal to negative 3. Okay. And you can always go back and check. So if x is negative 4, now if I square out negative 4 times itself is going to be a positive 16. 7 times negative 4 is negative 28. So you got positive 16 minus 28 is negative 12. And negative 12 plus 12 is equal to 0. Likewise, if I test out negative 3, the square of negative 3 is going to be positive 9. 7 times negative 3 is negative 21. 9 plus negative 21 is negative 12, plus 12 is equal to 0. So both of those values we check out. So there are two possible values for x and both of those we had to be negatives with -4 and -3. And we say that as second case here. Say we have a quadratic equation that is not quite in standard form. And we'll say that we have here x squared plus 15 is equal to -8x. Okay, so you have x squared plus 15 is equal to -8x. And to put this in standard form, I want to set this equation equal to 0. Okay, so I have the x squared term on the left-hand side, and that's joined with 15. But we have -8x out on the right. Okay, so I can just bring this over to the left by adding, and so just rewriting this equation in standard form. So you have x squared plus 8x plus 15 is equal to 0. So I have this set up whereupon I can factor. And with factors of x squared, I have going to x and x. Now for factors of 15, that will add up to 8. And because we have all the terms to be positive, our binomials will be of addition. So we have x plus 5, and x plus 3 is the factors. However, as we set them equal to 0, if you have binomials of addition and we set equal to 0, our solutions are going to be negative. So we have for x plus 5 equal to 0, we have x equal to -5. If x plus 3 is 0, we have that x is equal to -3. And again, you can always go back and check. Now I have square root of -5. -5 times -5 is 25. 25 plus 15 is 40. And -8 times -5 is also positive 40. Now for -3, the square root of -3 is positive 9. 9 plus 15 is 24. And -8 times -3 is also 24. So both of these will end up checking out. So you have -5 and also -3. All right. And tell you what, just for what we have in the case of, say, working with fractions and quadratic equations. And we'll say we have here, in terms of adding fractions, so let's see what we get for let's say you have 23/40ths, and say we have plus 41, and say we have over 100, and then we'll say we have minus 31, and we'll say that we have minus 31 all over 31/18. Okay, and in terms of quadratic equations, okay, let's see what we get for x squared minus 10x minus 24 is equal to 0. And also where we have x squared plus 36 is equal to negative 12x. Okay, so let's see what fraction we get from combining these ratios together. And also, let's see what value or values of x we get in these second and third problems. Okay, if we go ahead and look into these items, okay, so we're looking at adding fractions together. And okay, so we have three distinct denominators with 40, 100, as well as 18. And if we look at the numbers, okay, so we have with 40. So if I'm looking for the least common denominator, okay, so we have for 40, okay, you have, if you pick any two numbers that go into 40, it could be, let's say 4 times 10. Okay, and 4 would factor out to like 4 and 1, 2 and 2. And I want to break down 4 as well as 10 in terms of just its prime factors. So 4 we have 2 times 2. And 10, okay, we have 2 times 5. And so we have 3 2's and a 5 to make up 40. Okay, so this is the prime factor display. And for 100, so we have 100, okay, we say we have 10 times 10. And 10 times 10, okay, 10 is going to be 2 times 5. And just rearranging, so we have 2 times 2 times 5 times 5. And as for the number 18, okay, 18, we can say we have 2 times 9. 2 is a prime number for 9. Okay, we can break this up as 3 times 3. So we're going to have in the setup, okay, we have with the prime factors. Okay, so you have 2, 3, and 5. And as for what we have in the case of the least common denominator, okay, so you have with the number 2, okay, so you'll be looking at the highest representation from any one of these factorizations. Notice we have 2 appears once from 18. It appears twice from 100. But the kingmaker is going to come from 40 since 2 appears 3 times. And as for 3, it doesn't appear at all from 40 or 100, but it does appear twice from 18. And as for 5, okay, it doesn't come from 18, it appears twice from 100 and only once from 40. And what's going to happen here is that for the least common denominator, okay, this is going to be a rather large number, okay, because here we have 2 times 2 times 2 is 8, 3 times 3 is 9, 5 times 5 is 25, and the smallest number that 40, 100, and 18 will all go into, that is going to be at 1800. Yes, they have a rather large denominator here, okay, and so just taking what we have in the mix. So for 23 over 40, so I'm going to multiply this by 1 in the form of the number times at 40, we're going to 1800. And 1800 divided by 40, okay, that's going to be 45. And we have plus, okay, now for 41 over 100, 100 we're going to 1800, 18 times. So this ratio would be multiplied by 1 in the form of 18 over itself. And for 31/18, 18 will go into 1800 100 times. So for what we have in the setup, okay, so all three denominators, we'll have transition. Okay, so we got 40, 118, and then after the process, okay, we'll have the same denominator, which we have to be the least common denominator at 1800. Now, for what we have with the numerators, okay, so we have for 23 times 45, okay, that'll be 1035. Now for 41 times 18, 41 times 18, that'll be 738. And then we have minus, okay, 31 times 100, so it'll be minus 3,100. And so for what we will have in the mix, so we've got 1035 plus 738 minus 3,100, and in this particular case, this would be minus 1,327 all over 1,800, and that will be the result here. Okay, now in looking at what we have with the quadratic equations, and we have here, okay, so you have with x squared minus 10x minus 24 is equal to 0. Okay. And again, we have a factorable trinomial expression. And so for what we have in the setup, okay, so establishing, okay, what's going to be the zero product property. So from x squared, again, we'll have x and x. And it's now negative 24. Factors of negative 24, whose sum or difference will be on the negative side at minus 10. This will signal that more weight will be given to the subtraction than to the addition. So in this case, we'll have only x plus 2. And for subtraction, we have x minus 12. And looking at taking what we have with each of the factors and setting to 0. So we have x plus 2 is equal to 0. So we have x equal to negative 2. And for x minus 12 equal to 0, okay, we have x is equal to 12. And again, you can check for the consistency. Say for negative 2, the square of negative 2 is positive 4. Negative 10 times negative 2 is positive 20. 4 plus 20 is 24. Minus 24 is 0. So negative 2 checks. Now for 12, 12 squared is a large number at 144. Negative 10 times 12 is negative 120. And we have 144 minus 120 is 24. Minus 24 is 0. So both negative 2 and 12 will check out. And as for what we have in the case of the third item, and we have a quadratic equation that is not expressed in standard form. Okay, since we have negative 12x over to the right, and if I move the 12x over by adding, so looking at what we have here, so we have x squared plus 12x plus 36 is equal to 0. And if I look at factoring, it's going to turn out that we have a square trinomial since we have only one factor, which is going to repeat with x plus 6. And so we're going to have, for from this. Okay, there's going to be only one solution for x. And this will stem just from x plus 6. So for x plus 6 is equal to 0, we had that x is equal to negative 6. And again, the square of negative 6 is 36. 36 plus 6 is 72. And negative 12 times negative 6 is also positive 72. All right. Now, just some other instances of what we have with the quadratic equation. And let me just kind of mention just as other examples. If you're looking at solving for x, and let's say if you have coefficients that are even, and we have, in this case, we have negative 2x squared plus 8x plus 64 is equal to 0. And what I can do here, we have even coefficients, and I want to be able to work with x squared and not have a negative in the trinomial. So you can either divide by negative 2 or factor out negative 2. Now let's say if I factor out negative 2. So negative 2 into negative 2x squared is going to be x squared. Negative 2 into 8x, okay, so this will be a negative 4x. And negative 2 into 64, that's going to be a minus 32. And with this trinomial, okay, so if I factor, again we have x squared goes to x and x. And factors of negative 32, whose sum or difference will be at minus 4. So with the sum or difference at negative 4, more weight will be given to the subtraction than to the addition. So here we're going to have x plus 4 and x minus 8. Notice that we have 3 factors, but 2 are in the variable x, and the other one, okay, is just going to be a constant. So negative 2, in this instance, it is not doing anything with x, whether it's adding, subtracting, multiplying, or dividing. So negative 2 is just a constant, so this factor is not going to have any bearing in the subsequent steps in terms of solving for x. Okay, so with the zero product property, we take our x factors, or expressions in x, and set to 0. So for x plus 4 is equal to 0, okay, we have x is equal to negative 4. And we have with x minus 8 equal to 0, we have that x is equal to 8. Okay, and again, you can always go back and check. Like the square of negative 4 is 16. However, negative 2 times 16 is negative 32. And 8 times negative 4 is another negative 32. And negative 32 plus negative 32 is negative 64, plus 64 is equal to 0. And for 8, okay, we have 8 squared is 64. Times negative 2, so you would have like negative 128, and then you have plus 8 times 8, so you have negative 128 plus 64, which is negative 64, and then in turn adding 64, and that is also going to yield 0. So we have our 2 solutions for x at negative 4 and positive 8. And there's another case too, and I'm going to use this as a little bit of a segue to another technique. Yes. Question?
Why did you change the 4 to a negative 4 and the negative 8 to an 8?
Okay, what's happening here, okay, is that setting the factors to 0. If I have x plus 4 is equal to 0, in other words, to get x by itself, I'm going to take away 4 from both sides. And for x minus 8 equal to, yeah, okay, so there we go. Okay, so that's how I got to negative 4 and 8. All right. Yes.
Where did the negative 2 go?
Okay, you could have divided the equation by negative 2, but the negative 2, the reason I didn't involve this is that negative 2 is just a number. In other words, it's not doing anything with x from here on out. It's just a constant. In other words, if if I had, if I started out, okay, say that if I had,
Okay.
yeah,
So like you could just like throw it away. Like you don't need it at all.
right, and let me put it this way. Another setup I could have done is that if I divided the equation by negative 2, in other words, if I had divided the equation by negative 2 as opposed to factoring out, I would get this equation and I would still have the same results. Either way, it would still get you to the same destination.
Okay, thank you so much.
You're welcome. Okay. All right, and let's say that let's say if I have just x squared is equal to 4. Now there are at least a couple of techniques that I can use for this one. But let's say that just putting what I have here in the context of expressing as a quadratic equation in standard form. Okay, so if I have x squared is equal to 4 and I want to set this equation to 0. Okay, so we have here x squared minus 4 is equal to 0. And here I have a difference of squares. Okay, so x squared goes to x and x, and factors of negative 4. We have positive and negative 2. And if I set these factors equal to 0, okay, so if x plus 2 is equal to 0, okay, so I will take 2 away from both sides. So I have x equal to negative 2. And if x minus 2 is equal to 0, and I add 2 to both ends, okay, so we have that x is equal to 2. And again, you can go back and check. Square of negative 2 is negative 2 times negative 2, which is going to be positive 4. And 2 squared is 2 times 2, which is also going to be 4. So this is one technique. Now, for what we have as another technique, especially if you don't have a first order x term, okay, we can use what's referred to as the square root property of equality. Okay, and for what we have concerning this property, and this would be like for cases if you don't have a first order x term that is explicitly on display, and what this property states is that if x squared is equal to p, then you will have that x is equal to plus or minus the square root of p. And if you were to draw separately, okay, so you have the square root of p as well as the negative of the square root of p. And let's say just with the square root property of equality, okay, and I'll just call this SRP, solved by the square root property. And just taking what we looked at moments ago with x squared is equal to 4. Again, with the zero product property, I just set the equation to 0. But let's say that if I were to solve by the square root property of equality, so I have that x squared is equal to 4. Okay, and so I have x squared and I have p represented by 4. And if I go from x squared to x, and we have x equal to plus or minus the square root of p. Okay, so that would be plus or minus, okay, the square root of 4. And the square root of 4 is going to be 2, so I have x is equal to plus or minus 2. And so we have two possible values for x. Once again, so you have positive and negative 2. Same result as what we had just moments ago. Now for x squared, okay, that could represent the squares of other letters, and it can also represent the squares of multi-term expressions. And let me give you a case here. Let's say that x is represented by, let's say we have x plus 1. And we'll say that p is represented by 49. Okay, so I have not just x, but the square of x plus 1, and I have is equal to 49. And let's say that if I go from second degree to first degree, in other words, so get rid of the 2, so we have just like the binomial, x plus 1, or x plus 1 to the first, and you have your p represented by 49. Okay, so if I go from second to first order in the expression, that on the other side, I'm going to take its plus or minus square root values. Okay, so I've gone from x plus 1 to the second to x plus 1. And I have equal to plus or minus. Now the square root of 49 is going to be 7. And if you notice, you have x plus 1 could be 7, or x plus 1 could be negative 7. So if I split up what I have here, looking for the values of x. Okay, so if I have that situated that x plus 1 is equal to negative 7 on the lower end, and I want to solve for x. Okay, so get x by itself, I'm going to move the 1 over by subtracting. And here we're going to have that x is equal to negative 7 minus 1, which would be negative 8. And on the other end, if x plus 1 is equal to 7, and I take 1 away from both sides, okay, we'll have the x is equal to 7 minus 1, which will be 6. Okay, and you can always go back and check. So we have like negative 8 plus 1. Negative 8 plus 1 is negative 7. Negative 7 squared would be like negative 7 times negative 7, so that would be 49. And as for 6, 6 plus 1 is 7. 7 squared is also positive 49. So those would be our two solutions for x in this particular instance. And let's say that, now for these solutions, okay, we have to come out fairly cleanly as integer values. But you also might have some irrational roots in the mix. I'll give you just an instance here. If I have, let's say, the square of x minus 2 is equal to 15. Okay. And just kind of provide a little bit of a visual aid. So again, we're still using the square root property of equality. So what I have here, okay, this represents, okay, the x squared is equal to p stage. And if I cross over going out to x is equal to plus or minus the square root of p. Okay, so going from x squared to x, here I had the square of x minus 2 to just x minus 2. And plus or minus the square root of p, this would be plus or minus the the square root of 15 and just looking at what we have here. Okay, so you have x minus 2 is equal to plus or minus, okay, the square root of 15. And let's say if I get x by itself now, so you have x minus 2. And let's say to get rid of the minus 2, I'm going to add 2 to both sides. And what I'm going to do here is that for the square root of 15, that is not a perfect square number, like 49 or 16. So I'm going to leave the square root of 15. This is not reducible, so I can leave plus or minus the square root of 15 as it is right now. And as I'm looking at adding 2 to both sides, what I want to do is that upon adding 2, so we have 2 plus or minus, okay, the square root of 15. Now for compact notation, okay, so we have x is equal to 2 plus or minus the square root of 15. And if you were to itemize, you would have at the upper end, okay, we have 2 plus the square root of 15. Now at the lower end, you would have 2 minus, okay, the square root of 15. And so those would be the results in this case. Okay, so if you have irrational roots, like radicals that cannot be reduced, and you got plus or minus the square root of whatever constant you're moving to its side, normally the orthodox notation would be to have that value in front of the plus or minus, just like what I did with 2 just a moment ago. Okay. And we'll be looking at some additional examples here. Now let's say that in the case of looking at solving by the square root property, okay, let's say first of all, okay, just see, we have x squared is equal to 100. And second, we'll say we have a binomial expression. We'll say we have x minus 3 squared is equal to 16. And then we'll have in the mix, we'll have the square of x plus 4 is equal to 37. Okay, for these items, okay, looking at solving by the square root property, okay, so we have in the first equation, we have x squared is equal to 100. So again, if I go from x squared is equal to p to x is equal to plus or minus the square root of p, so I have x is equal to plus or minus the square root of 100. And 100 is a perfect square number, so we have plus or minus 10. So you have with our solutions of x, whose square will end up at 100, we have negative and positive 10. Okay, and for what we have in the next item, and we have with the square of x minus 3 equal to 16. So if I go from second to first degree in x minus 3, so you have x minus 3 is equal to plus or minus the square root of 16. Then we have the x minus 3 is equal to plus or minus, and the square root of 16 is 4. And if we just itemize, so we have one value of x will come from setting x minus 3 to negative 4, and the other will come from setting x minus 3 to positive 4. So if x minus 3 is equal to negative 4, so I can isolate x upon adding 3 to both sides. So I have that x is equal to negative 1. And for x minus 3 equal to 4, if I add 3 to both sides here, we'll have the other solution for x, okay, which is going to be at 7. Okay, and you can always check. So 7 minus 3 is 4. 4 squared is 16. And we have a negative 1. Negative 1 minus 3 is negative 4. Negative 4 squared is also 16. All right. Now for what we have in the third case, all right. So you have the square of x plus 4 is equal to 37. And for what we have in this one, again, unlike 116, okay, 37 is not a perfect square number. In fact, it's a type of number that's even such that the square root cannot be a reduced radical. Okay, so if I go from the square of x plus 4 to just x plus 4, okay, so I have x plus 4 is equal to plus or minus the square root of 37. Okay, now in exact terms now, we were able to get plus or minus the square root of 100 to plus or minus 10. And I was able to get from plus or minus the square root of 16 to plus or minus 4. But I cannot get any integer from the square root of 37. So if I were to say go ahead and split up, so we have with x plus 4 equal to the negative of the square root of 37. And again, you can also do the compact notation. So I have with x plus 4 equal to the negative of the square root of 37. So I can take 4 away from both sides, and here I'm going to situate the negative 4 in front of the radical. And so we'll have x, we have at negative 4 minus the square root of 37. And as for x plus 4 equal to the square root of 37, applying the same kind of treatment here, so we have x plus 4 minus 4 we have is equal to, and I'll just have the constant in front of the radical, so you have negative 4, and this will be plus the square root of 37. And so here we have negative 4 plus the square root of 37. And we have in itemized terms, okay, which Alex would be looking at. So you have negative 4 minus the square root of 37, and also negative 4 plus the square root of 37. But again, if you had compact notation, again, this would be like negative 4 plus or minus, okay, the square root of 37. Okay, so with potential methods of solving for quadratic equations, again, where factoring can be done, we have the zero product property, and included, okay, we have the square root property of equality, and there's going to be yet another technique that can be utilized. Okay, and again, just going back to the general expression for the quadratic equation, And again, we have a quadratic equation is a second order equation whose standard form is ax squared plus bx plus c is equal to 0. Once again, whereupon a cannot be equal to 0. And for what we have in the case of x, now the derivation is going to be kind of complicated, but from working with solving for x and putting in terms of what we have with the other variables, a, b, and c, we have what's going to be the quadratic formula. And this is where, just taken from this equation, we're going to have x is equal to negative b plus or minus, okay, we have the square root of b squared minus 4ac all over 2a. And once again, this is where a cannot be 0. And now for the quadratic formula. Now you can use it when the trinomial involved is factorable, and it can also be used when the trinomial is not exactly factorable. And let's say that if we have just quick instances here. Okay, if we're looking at solving, okay, by the quadratic formula, and we'll say that we have, as the case here, let's say we have 2x squared plus 7x plus 1 is equal to 0. Okay, so we have a quadratic equation in standard form. Now this one I cannot factor into integer coefficients, and even if you tried factoring by grouping, you'd have like 2 times 1 is 2, and factors of 2, okay, you only have 1 and 2, and 1 and 2 or negative 1 and negative 2 will add up to 3 or negative 3, but there's no combination that will add up to 7. Okay, so for what we would have in terms of finding any solution that might exist, okay, is that taking what we have to represent a, b, and c. So from 2x squared, okay, we have a is equal to 2. And then from 7x we have b is equal to 7. And from the last of the trio we have the constant c is equal to 1. And with what we have with the use of the quadratic formula, okay, okay, so if I were to substitute accordingly, okay, so we have negative b, okay, now b is at 7, so I'm going to take the negative of 7. I have plus or minus the square root, okay, now b squared, okay, so b squared is going to be 7 squared, and minus 4ac, so you have minus 4, a is at 2, c is at 1. And we have all over 2a, so that's going to be 2 times 2. And just, okay, so all thing I've done here is just substitute and just taking what we have in the follow through. So you have negative 7 plus or minus. Okay, now the square of 7, or 7 times 7, that is going to be 49. And minus 4 times 2 is negative 8. Negative 8 times 1 is still minus 8. And 2 times 2 is going to be 4. And so for what we will have here, Okay, we have negative 7 plus or minus the square root. And 49 minus 8 is going to be 41. Okay, we have all over 4. And again, if you itemize, okay, we have at the upper end, we have negative 7 plus the square root of 41, all over 4, and negative 7 minus the square root of 41, and we have also over 4. And pretty much, okay, now the negative b, the 2a, and the b squared are many seem to get pretty quickly, but it is with the negative 4ac that it is very easy to make a careless mistake. I'm going to give you just another example here, and where we have negative terms in the equation, and we'll say that we have 2x squared minus 9x minus 1 is equal to 0. Okay, so just looking at what we have here. Here we go. So we have 2x squared minus 9x minus 1 is equal to 0. So we're going to have, once again, we have representing a, we have it 2. And from negative 9x, okay, so the coefficient b is going to be negative 9. And for c, this is going to be at negative 1. Okay, so utilizing what we have in the quadratic formula. Okay, so if you notice, okay, this is where you have to be careful, especially when you have negative signs. Okay, b is at negative 9, and the formula, we're looking at the negative of b, so we're looking at the negative, or the opposite sign of negative 9. And we have plus or minus, okay, the square root. Now for b squared, we have negative 9 squared. And you have minus 4ac, so you got minus 4 times a, okay, whereupon a is going to be at 2, times c, so we have at negative 1. And we have all over 2a, which is going to be 2 times 2. Okay, so this display is just with the direct substitution. Now, the opposite sign of negative 9, this will translate to a positive 9. And we have plus or minus, okay, the square root, the square of negative 9. Again, if you're using a calculator, do not forget to put your negative values in parentheses. So negative 9 times negative 9 is going to be a positive 81. Now for the minus 4ac part, okay, had to be careful with. Negative 4 times 2 is negative 8. And then in term, we have negative 8 times negative 1 is going to be a positive 8. And so we have 9 plus or minus the square root of 89. All over 4. And again, if you were to itemize, we have 9 plus the square root of 89 over 4, as well as 9 minus the square root of 89, also over 4. All right, and just some items here. Now, I was going to mention something about conditionals, contradictions, and identities, and I think I'm going to hold off on that until next time. But it'll be part of the set of exercises that you'll go ahead and be looking into, and that's going to be at the front. And so just for next time, okay, items can go ahead and look into. And we have from page 68. Okay, we're going to be looking into numbers 24, 26, and 28. And then where we have 24, 26, and 28, that's like that conditional, identity, contradiction. That's where this is sort of a little bit of future material, but where we had the quadratic equations that come in, we have in numbers 30, 34, 35, and we have just rounding out the rest. Okay, so you have 40, 41, and also number 64.